Hello, my name is John Kelly and this is the Weber Auto YouTube channel. This video is the third in a series on the evolution of the Toyota Prius hybrid transaxle. As you can see sitting behind me here, I have a third generation Toyota Prius. This model went up for sale for the model years of 2010 through 2015. So this third generation Prius has a very unique, totally redesigned transaxle called the P410. So let's go take a look at it. Okay, we are ready to install the gears and the MG2 rotor and talk about how this new design P410 transaxle has evolved into a better design that gets better fuel economy, is more efficient, and actually has a lot more power than the P112 transaxle in the second generation Prius. So to do that, let's look at the components one by one. Of course, we've got the rotor, MG1 rotor here. MG1 stands for motor generator number 1, which is our starter and generator. It starts the internal combustion engine. It provides power to MG2 right here to help move the vehicle down the road, and any excess power is routed to the 201.6 volt battery, same as in the second generation Prius, in the back of the vehicle. It's a nickel metal hydride battery. Just like in the first and second generation Prius transaxles, the rotor, MG1 rotor, drives a sun gear. So if that rotor rotates at all, it turns a sun gear of a planetary gear set. Now, there's three main components to a planetary gear set. A sun gear is one of them, and it is in the center and, of course, rotates. The second piece is the Planet Carrier. Now this piece right here is the Planet Carrier, and this sun gear would fit right up inside of it, just like that. But the Planet Carrier on the Prius, or on all Toyota hybrid transaxles, is connected to the internal combustion engine through a clutch damper, which limits the maximum amount of torque transferred from the engine to the transaxle or backwards from the transaxle back to the engine. There's a clutch that'll actually slip in here if the maximum torque is exceeded. And then of course there's a flywheel that bolts to the engine crankshaft and rotates at engine crankshaft speed. So out of the three pieces of a planetary gear set, we've got the sun gear that rotates with MG1, we've got the Planet Carrier that rotates with the engine, and then on the first and second generation Prius, MG2 right here was connected to the ring gear or internal gear. So here is a ring gear or internal gear, as it's called in many books. Sometimes it's called an annulus gear also, but the gear is on the inside here. And this, on the first and second generation Priuses, was hooked directly to MG2, and MG2 is what's responsible for driving us down the road. We do not move down the road unless MG2 moves. All right, so in the first and second generation Prius, that's all we had was those three pieces. Well, in this third generation Prius and this P410 transaxle, which remember is a baby version of the P310, 311, 312, 13, and 14 transaxles that are used in other Toyota hybrid vehicles like the Camry, the RAV4, the Avalon. They all use a version of this also that's just bigger, heavier, 267 pounds, more heavy duty, more torque, more power. But for this smaller version here for the Prius, obviously that's the one we're looking at today. So what they've done here in this new design is add a second planetary gear set. So instead of just one planetary gear set, which was called the power split device in the first and second generation Prius, we now have a second planetary gear set called the motor speed reduction gear set. So let's so we can understand how that works, let's take our flywheel and get it in place here where it goes. It'll spin with the engine. We'll take our Planet Carrier, make sure it's got its bearings. Yes, it does. Get it lined up and into the flywheel. Notice neither one of these are directly connected to each other. The flywheel is not connected to MG1. MG1's not connected to the flywheel. They can rotate around each other. And if we rotate both of them the same speed, then they're the same speed and direction, then they're locked up and act as one and can contribute torque to MG2 as we drive down the road. And then we can play with the rotational speed of MG1 to vary how much engine torque is added to the torque of MG2's rotor anyway. All right, so there's a ring gear or internal gear that goes right here. And what they've done to add a second planetary gear set in this P410 transaxle is they've combined both ring gears into one housing. So the ring gear here on the bottom is the ring gear for the MG1 rotor and the engine itself. That's the power split device ring gear. Here on the other side, we have another ring gear or internal gear for the motor speed reduction gear set. And so this whole thing just sits right down in there, just like that. All right, so from here down, we have the power split device that basically is determining how much power is added to move the vehicle down the road. This gear right here on the outside of this set of ring gears is what connects to the counter drive gear and the final drive gear. So on this third generation Prius, the P410 transaxle, they got rid of that drive sprocket chain and driven sprocket and counter drive gear and counter driven gear and final drive gear mess, and now they just have a counter drive gear, a counter driven gear, and the final drive. That's it. So the two ring gears that are right here for the two planetary gear sets have an external drive gear called the counter drive gear, and notice if it rotates, notice that the final drive gear back over here also is rotating. So if we can make this ring gear rotate at all, then the vehicle will move. Now we can make that ring gear rotate through the engine side by turning the engine and then dragging the, or not dragging, but affecting the rotational speed of MG1. We can send torque to the bottom side as it's positioned here, the engine side of that ring gear, and make the vehicle move. So we've got a torque path coming that way. But if the vehicle is stopped and we run the engine, then we're just turning the MG1 rotor generating. But driving down the road, we can turn these two at exactly the same speed, the flywheel and the MG1 rotor, that would connect engine torque to this gear and drive it down the road. So that's one possibility. But it's never done it never does that by itself. It always has to have MG2 moving the vehicle down the road as the primary source of power. Now, here on the top ring gear here, which is called the motor speed reduction gear set, it has another planetary gear set. So right here on the MG2 Rotor, we have a sun gear that has 22 teeth. We have a Planet Carrier right here, another Planet gear, like the Planet gear that connects to the flywheel here. And it has 18 teeth, and then the ring gear has 58. By the way, the bottom planetary gear set here, the power split device, the sun gear has 30 teeth, the Planet gears are 23, and the ring gear is 78, if you want to do the math and come up with a gear ratio of 2.6 to 1 from MG1 to the ring gear, and then a gear ratio of 2.636 to 1 from MG2 to the drive gear here on the, there we go. So this Planet Carrier sits down inside of that upper ring gear, the motor speed reduction ring gear. Now, as this label shows right here, this Planet Carrier is held stationary. All right, the last piece of the puzzle here is the MG2 rotor assembly itself. If we compare that to the MG2 rotor of the previous two transaxles, it's about half the height. It's a little bit larger in diameter. It has the V-shaped magnets. It's also rated for 207 Newton meters of torque or 153 pound-feet of torque. And this sun gear right here fits right down inside of that motor speed reduction gear set. Now, if we compare that to the second generation transaxle as far as the power ratings, let's see, we've got 80 horsepower and 153 pound-feet of torque. The second generation transaxle has 68 horsepower and 295 pound-feet of torque. So at first glance, you might think that the 68 horsepower, of course, is lower for the second generation, but the 295 pound-feet of torque on the second generation is much higher than the 153 we have here on the third. But you've got to remember, we now have another planetary gear set for gear reduction here on this third generation transaxle. So what happens is we have to take that torque of 153 pound-feet of torque and multiply it by the gear ratio of 2.636, and we come up with 403 pound-feet of torque delivered to this ring gear from MG2. Now that does not take into account any frictional losses from the gears contacting each other. That's just theoretical maximum torque. So it's going to be a little less than the 403, but it's a lot more than the 298 that we had on the MG2 of the second generation transaxle. So the horsepower went from 68 horsepower up to 80. The theoretical maximum torque went from 295 pound-feet of torque to 403 pound-feet of torque. And I can tell you from owning a second or third generation Prius myself for 2 years that it had plenty of acceleration. It was very fun to drive. Notice the forward direction of rotation on this MG2 now is backwards of what it was on MG1, and that's because instead of using two counter gears, we're only using one counter gear. But if we rotate the MG2 rotor this direction, the vehicle will move forward if we hold this motor speed reduction gear set Planet Carrier from rotating. So one of the guys here at the shop built a little bracket for me to hold the Planet Carrier from rotating while I do demonstrations like this. Just a little metal bar that comes in from the back here, goes into one of the notches. Now the Planet Carrier is stationary, and so now let's watch the final drive gear here rotate. Because of the additional gear reduction here in the motor speed reduction gear set of 2.636 to 1, it's going to take more rotations of MG2's rotor to get one rotation of the final drive, which equals the rotational speed of the tires. So this time, through all these gears, it's going to take 8.6 turns of MG2 to get one rotation of the final drive here. So let's check that out. Notice the sticker location here. So let's make this rotate one time. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, and 8.6 is about half, a little more than half over here, and our sticker is back to where it was. So that means this MG2 rotor did not slow down, it sped up. So the name of this second gear set here, the motor speed reduction gear set, makes no sense to me. It drove me crazy for quite a while, thinking, why would they call it a motor speed reduction gear set? Because all the descriptions in the Toyota service information say it's to reduce the speed of MG2. Well, obviously it doesn't. It sped it up by a factor of 2.6. Instead, after playing with these transaxles and doing calculations, what it does is it reduces the speed of MG1. I believe there's a typographical error in the Toyota service information that's just been propagated on and on and on. And what happens is while you're driving down the road, in the first and second generation Prius, in the first generation Prius, this rotor, MG1 rotor, had a maximum speed of 6,500 RPM. And in the second generation Prius, it went to 10,000 RPM. In this third generation Prius, it's at 13,500 RPM. By the way, in the fourth generation, it's at 17,000. But as you are driving down the road in electric vehicle mode, EV mode, with the engine off, it has a gear ratio here of 1.014 turns of MG1 to 1 turn of MG2. In other words, they spin almost exactly the same speed. We are not going to over-rev in EV mode MG1. So on the first and second generation Transaxle, they had a gear ratio of 2.6 turns of MG1 to just 1 turn of MG2, which meant in EV mode, you could not drive very fast without exceeding or meeting the maximum RPM of MG1. And the only way to slow it down was to start the engine and have the engine affect the rotational speed of MG1 and even the rotational direction of MG1. So the motor speed reduction gear set, in my opinion, is to reduce the speed of MG1 rather than MG2. The power rating, the torque rating of MG2 went down, but through the torque multiplication that takes place through gear reduction, we increased the torque over the previous design, and our horsepower rating is higher. We have a MG1 gear ratio to MG2 gear ratio of just a little over 1 turn, 1.014 turns. So as I turn MG2 one rotation, this will turn a little more than one rotation, 1.014 rotations. And once again, that would only occur in electric vehicle mode, like in the plug-in, the 2012 through 2015 plug-in Prius, the plug-in hybrid vehicle. In EV mode, you could drive clear up to 61.5 miles an hour before the engine had to come on, and I'm sure that had something to do with the rotational speed of MG1 and how much energy it took to even propel the vehicle down the road in MG2 versus the current availability in or from the battery itself. So if I punch in, I've done some calculations here. If I punch in 61.5 miles an hour with an engine speed of 0 for the P410 transaxle here, the MG2 rotational speed is at 7,400 RPM. It's 7,400 RPM at 61.5 miles an hour. MG1 is at 7,800 RPM, which is nowhere near the maximum of 13,500. So it's not because of over revving. It's because it's got to be because of we need more energy to propel the vehicle faster with the wind resistance and rolling resistance of the tires and so on. Okay, so the last piece of the puzzle here is our oil pump drive, and it splines to the planetary carrier that hooks to the crankshaft of the engine. So notice as I turn the flywheel, the oil pump drive gear rotates also. So let's just do an overall summary of the operation of the P410 transaxle here with its 2 planetary gear sets. So we've got the internal combustion engine through the flywheel that connects to the planet carrier of the power split device planetary gear set. It still has the same gear ratio between the flywheel and MG1 that the first and second generation Priuses did of 3.6 turns to 1. In other words, if I stop MG2 from rotating and I rotate the crankshaft, MG1 spins 3.6 times faster than the engine does. And that's the faster that spins, the more power is generated to recharge the battery. That's why your engine cycles on and off. Your battery power, high voltage battery power goes down low, it starts the engine. This powers up and recharges it and then shuts back off. The engine in combination with MG1 can contribute torque to this outer gear here in this set of ring gears for the 2 planetary gear sets. But the number one source of torque for moving the vehicle down the road is MG2 through the motor speed reduction gear set. And notice if I turn MG2 at all, either direction, if I move MG2, this gear is moving. So MG2 is what moves the vehicle down the road. Notice that if I hold the ring gear from rotating, I can turn the crankshaft, I can turn MG1. Neither one of those force the engine to, or force the gear to rotate and move the vehicle down the road. They can only contribute torque to the ring gear, which is what MG2 is driving anyway. Now, a few theoretical things about a planetary gear set, and that is if you turn any 2 components the exact same speed, you lock up the entire planetary gear set, and it all turns as one assembly. So in other words, if I lock the sun gear, which is connected to the MG1 rotor, to the flywheel, if I turn these 2 together, notice that the ring gear, the third piece, rotates with it. So if we lock these 2, or not lock them, but if we rotate, if we cause MG1 to rotate electrically the same speed as the engine RPM, we are delivering all of the engine torque right to this gear to help MG2 propel the vehicle down the road. If we don't lock them together and we have some slip, then we're delivering less than full engine torque, or whatever the torque is at that engine RPM, to MG2. So we can make it be absolutely nothing, which is what it is right here, to a full maximum, which is what it is when we hook the 2 together. It's a variable. It's a electronically continuously variable transmission as far as the engine RPM to the drive of the transaxle itself. In our next episode, we are going to look at the P410 transaxle, which was used in the Prius C. And then finally, after that, we will get into the brand new P610 transaxle that's used in the 2016 and above Prius and the 2017 Prius Prime. Thank you for watching. Have a good day.